Now, let's turn to Fedora's data model. Fedora also has nice documentation with pretty pictures, so I'm going to lean pretty heavily on those because why reinvent the wheel? As it says in the Fedora documentation, Fedora, quote, Fedora uses a compound digital object design, unquote, which means that objects in Fedora can be what are called compound objects or complex objects, which is to say an object is made up of more than one object, which sounds a bit confusing when I say it like that, but it's actually very common. Think of a web page, any web page. It's made up of text plus embedded images plus perhaps embedded videos plus who knows what else. Right? Let's take, for example, a YouTube page. The object that is the page is made up of a bunch of different components. The video itself, plus a bunch of text blocks, the metadata created by the user who uploaded the video, the comments, the images down the right-hand side and links to other videos. A YouTube page is a very complex object. It's one object made up of lots of other objects of lots of different types. Now, Fedora is designed with complex objects in mind. It's designed to make it comparatively easy to create complex objects. Comparatively easy compared to, say, Omeka, where it would be impossible because Omeka has this unitary approach to items. So, how do you design an application to make it easy to create complex objects? You start by making the persistent identifier the first class object. The most important type of entity in the Fedora data model is the persistent identifier. Now, a persistent identifier can be a DOI, a URI, whatever, some address to a web space that will be persistent over time, and there are a variety of ways of doing this, which I'm not going to get into here. So associated with that persistent identifier are a set of properties. Among those properties can be identifiers to other objects. So what you've got is a pointer to an object that's really a collection of objects. So that object is really made up of pointers to other objects. Again, this sounds kind of nutty, but it's actually a pretty common approach. Look at Amazon, for example, or really any database-driven website, which basically all storefront sites are these days, take your pick. This page that you're looking at now doesn't really exist. It's a bunch of separate elements thrown together on the fly into a template. All Amazon pages look more or less the same. And why is that? This is because they have a shared template. The template dictates put the title here, put the author name here, put the image of the cover here, put the price there, put the reviews down there, etc. All those pieces are individual elements in a database record for this item. And when you click on a link for this item or do a search for it or what have you, they're thrown together to make a web page at that moment. This page did not exist as a static thing prior to the moment when I searched for this book. This is not a perfect analogy for how Fedora works, but at least it's a familiar example, and it's similar enough. When you clicked on the link for this book, all of these different elements were grabbed out of a database and thrown together into a template. And how did Amazon's software find those elements? Because they are all addressed uniquely as elements of the database record for this item. Similarly, an object in Fedora can be made up of other objects. As long as everything has a unique ID, it's all cool. So each object in Fedora each object in a Fedora object is made up of what the Fedora developers call a data stream, which is more or less the same as a bit stream in DSpace. Bit streams can be the content itself, managed by Fedora or hosted outside of the Fedora instance, right? You can create a pointer to something that lives outside of your instance of Fedora. And bit streams can be metadata about the content, like the MIME type or a checksum, which is error checking data, but I'm not going to get into that right now, etc. I want to go off on a tangent for a moment and talk about a feature of Fedora that's not strictly speaking related to its data model, though it kind of is. And that is the representation of an object. Remember that each unique object in Fedora can include multiple data streams. And what's more, an object can include more than one representation. So what you can see in this figure is that there are a set of different representations for a single object. There are 3 data streams and 3 representations. Right? This particular object, which is called Demo 11, is an image that can be displayed as a thumbnail, a high-resolution image, or as Dublin Core DC metadata. So a single object has 3 distinct data streams that can be displayed differently. Also, what you have is what are called in Fedora disseminators. Now, a disseminator is a set of instructions for how Fedora should represent an object. And by instructions, I mean code, software. Basically, an object can include algorithms within it, or I should say it can include a pointer to an algorithm. In this figure, there's a disseminator, an algorithm, that can convert the high-res image, and notice that it's only attached to the high-res image, can convert the high-res image to new formats and display the high-res image as a grayscale image, for example. Or it can launch a separate application, probably embedded in the browser window, an app that will display the image in something that will allow zooming, right, the zoom view. Right? So what we've got is an object with 3 data streams, each of which is a unique display of that object, and one of those data streams has a disseminator associated with it that can represent the high-res image in 2 other ways. So what we've got here in Fedora is a data model that's centered on unique identifiers, which enables the creation of complex objects. And those complex objects can be arbitrarily complex. All you need to do is add more unique identifiers, point to more things, and add complexity to your object. Those unique identifiers can point to any type of thing, any type of data, right? A Dublin Core metadata record, a high-res image, a thumbnail image, etc. Right? A unique identifier can point to any type of thing or even an algorithm. Now, this is a huge contrast with Omeka and its incredibly simple data model. And it's even quite a contrast with DSpace and its community-based data model. Fedora is a much more complex data model that supports a much wider range of displays of items.